Up to this point, we've only used the ordered pairs x comma y to represent points. We plotted these points x comma y in the Cartesian plane. In this section, we're going to have another way of representing points called polar coordinates. What we have drawn here is a Cartesian plane with the x-axis and y-axis labeled. We call the point in which the x-axis and the y-axis intersect the origin. Now what we're going to do is have another way of representing points. I'm going to refer to the origin as the pole. Then we're going to have a polar axis, which is going to go in the same direction as the positive x-axis. Then we rotate an angle out from the polar axis. The measure of the angle is theta. We then compute the distance from the pole to some point. We're going to call that point r comma theta. So r is the distance from the pole to the point, and theta is the measure of the angle. What we're going to do now is go through the process in which we're going to plot points using polar coordinate system. Let's see what we obtain. What we have drawn here is the point 2 comma pi over 4. We should recognize that the angle from the polar axis to the terminal side is pi over 4 radians. The distance from the pole to the point is 2 units. Because of the fact that there are an infinite number of angles that would have this as its terminal side, there are an infinite number of ways of representing the point 2 comma pi over 4. For example, what would the angle be if we went all the way around and rotated one full revolution and then another pi over 4 radians? Let's see what we would obtain. Because one full revolution is 2 pi radians, we would have 2 pi plus another pi over 4. That would give me 9 pi over 4 as the angle. Notice that is the exact same point that we had when we plotted 2 comma pi over 4. Could we also rotate in the clockwise direction? The answer is yes. What would the angle be then? In that circumstance, the angle would be negative 7 pi over 4. We'd still have the same terminal side. The distance from the origin to the point is still 2. So the point would be 2 comma negative 7 pi over 4. The result that we should conclude is that there are an infinite number of ways of representing the same point in polar coordinates. This is different than Cartesian coordinates, in which each point was uniquely represented in the Cartesian plane.